This is lab 1 on charge tapes for physics 2212. So the purpose of this lab is to explore the idea of charge, which is a property of matter, and to determine the amount of excess charge on everyday objects. Using clear tape that is charged, observations of their interactions can be used to approximate how much excess charge they have. This acts as an experimental model. A theoretical model is then used to calculate the electric field produced by a point charge given a charged particle and an observation location in GlowScript. This lab explores the concepts of Coulomb's law, which is K times Q1 times Q2 over R squared, where K is Coulomb's constant, Q1 and Q2 are particle charges, and R is distance. Newton's second law, which is F equals ma, and Newton's third law, which is when one object exerts a force, there is an equal and opposite reaction, as well as gravitational force, which is mass times the gravitational constant. So assumptions in this lab are that a long tape acts as a point charge with the charge at the center of the long tape. Each U-tape has the same amount of charge, and the air resistance is negligible. So the procedure is to create a charged U-tape by quickly ripping a clear piece of tape off of base tape, and then hanging the U-tape vertically from the edge of the table, and then determining its object with a hand, charged plastic pen, and a neutral object, bringing two U-tapes close together and observing their interactions with each other, and then making two U-tapes and placing one across two stable objects and observing how close one U-tape must be brought to the other to make it float. And throughout these procedures, handle the U-tapes the U-tapes need to be handled as minimally as possible. So some observations are between different interactions. So U-tape with a hand was attractive, U-tape with a neutral object was attractive, two U-tapes were repulsive, U-tape and negative object was attractive, and then the distance between the U-tapes to make the other U-tape float was 2.8 centimeters or 0.028 meters. So with these interactions, we can conclude that the U-tape was positive. So here are some measurements that were used for calculations, and as we can see, we measured that the charge of the U-tape was equal to 1.133 times 10 to the negative 8 coulombs. So here's the GlowScript code for the theoretical model to calculate using Python. So first we input the constants that are used for calculations. Then we find gravitational force, which is mass times gravity, and electric force, which is the magnitude of gravity because the forces are balanced. And then we need to rearrange Coulomb's law to find K. And then we need to find the distance and magnitude and use distance over magnitude to find the unit vector. So this is the experimental model and the results. So the green arrow is the gravitational force and the yellow arrow is the electric force. And so the tape's charge is 1.13 times 10 to the negative 8 coulombs, which is also similar to what we calculated by hand. And the number of electrons is 7.08 times 10 to the 10th. And the number of atoms is 2.85 times 10 to the 17th. And so some conceptual questions. If electrons had a positive charge and protons had a negative charge, then that would not change the observations because everything would have been the same because positive and negative are arbitrary. So if everything else in the experiment was kept consistent, then the results would be the same, and the interactions that attracted would still attract and the repulsions would still repel. And it's important to handle the charge shapes as little as possible because charge shapes have excess electrons, and negatively charged objects tend to have excess electrons move towards more neutral objects. So as the charge shape was handled, it was losing electrons and becoming more neutral. Thank you.